last example here, or sorry, the second to last example, example 5, is looking at coordinates. So F, we are told, has 2 coordinates, 1D, that should have been a comma there, and 3E. F has 2 coordinates, 1, 2. G has 3 coordinates, 1, 2, 3. Now remember, letters represent variables, so we're not really too concerned about what these letters actually are. We just know that they represent the coordinates. Find f of g of x. So we want to find what is the composed function. Now, because both our functions are just a set of coordinates, we are expecting f of g of x to also be a set of coordinates. We got to find out what are the coordinates for f of g of x. So f is the outside function, g is the inside function. The x's of the inside function, a, b, c, is what we're going to use for our potential coordinates here. A something, b something, c something. Right? Now, for the y values, that's what we're trying to figure out. So we're putting in a, b, c. What are we going to get out? In order to do the composition, we need to take the y values from g because they become the x values for f. So f of g of a is the same thing as writing f of 1, right? Because if I put a into g first, I'm going to get the y value 1. So g of a is 1, and f of 1, when I put x as a value into f, I get d. So f of g of a gives me d. So if I put in a into the composition, I end up with d. What's my next value here? F of g of b. If I put b into the g function, I'm going to get a y value of 3. So this is like saying f of 3. Well, if I put 3 into the f function, I'm going to get a y value of e. So f of g of b gives me the letter e. Right? Okay, now f of g of c. This gives me a y value from g of 5. However, f does not have an option for 5. So this does not exist. D and E does not exist. So it's impossible for us to have 3 points here because f can only handle 2. And it can only handle values of 1 and 3, which we have to get from G. So in conclusion, if we start with an x coordinate with the letter A, and we put it into G first, and then we put it into F, we are going to get a y coordinate of D. Then, if we put in an x coordinate of B, first into G and then into F, we are going to get a coordinate of E. So the composed function has coordinates AD and BE. Just in case we didn't have enough letters in math, just switching it up, having more fun. We'll do more examples in class as well. This is just a demonstration of the different ways we can use composition of functions. Okay, now we have 2 graphs. One is labeled H and one is labeled G, so that's clearly wrong. Let's relabel these. Since G is already on here, let's call this one F of X. Okay, use the graph of the 2 functions and find f of g of 1, meaning our outside function is f, Our inside function is g, and instead of a generic x value, I want to specifically look at 1. So first, let's identify what is g of 1. So when x is 1, what is the function of g? If x is 1, then I'm going to go find the g of x. Here it is. G of x is going to be negative 1, 2, 3. So this is saying f of negative 3. I guess I should keep consistent with my pen here, which is going to give me, now again, I have put in negative 3, 1, 2, 3, and I go up. Oh, it's kind of an in-between number there. Looks like about 1.5. This is going to give me negative, oh no, sorry, positive, because we went up from the x-axis, positive 1/2. So this is f of g of 1 gives me 1/2. We also can use composition to do a function inside of itself. There is no rule that says we can only use 2 functions. We can even do 3 functions at some point. So g of 5. So that means I'm going to evaluate what is g of 5. And whatever number I get, I'm going to put it into the g function again. So inside of the function first. G of 5 is positive 1. So this is g of positive 1. And g of positive 1, we actually just did it in the one before, is going to give me negative 3. Okay, so we're using the graph. The input number, so the 5 and the 1 in this case, is your x value. And you're going to do the inside function first, find the y value, take that number, and then put it into the outside function to get the final y value. Okay, if you've stayed with me up until this point, congratulations. You have done the bulk of this lesson. In the next page, if you are planning to take Calculus 12, please watch the next video. If you are not going to go on to Calc 12 next semester, then you can skip over this section. It is valuable. It is very interesting. It's essentially going backwards from where we started. But I'm not going to make it mandatory for this semester. So if you are in the School of Science or you are planning to take Calc 12 next semester, please go on and watch the next part of the lesson in the next video. If you are not in the School of Science and or you are not going to take Calc 12 next semester, we're done. These are the examples you need. Please go ahead and do the homework for this section. Anywhere where you see questions talking about decomposition, you won't have to do them unless you are in the School of Science and or taking Calc 12 next semester. All right. All right. Have a good afternoon, everyone.